All right, thanks everybody. Appreciate you guys coming out to our session today. I'm going to get right into it because we've got a lot of stuff to go over and a lot of fun things to actually get into. But I wanted to just really quick go through an agenda, and then I'm going to actually hand back to Justin because who knows best about NVIDIA cards and GPUs than Justin. For those of you who don't know me, I've been at NVIDIA for about a month and a half. Came from Citrix prior to that. So definitely know the infrastructure, the virtualization side of the fence, the Zen app, Zen desktop, those pieces. But when it really comes down to the market of who NVIDIA is, what a GPU, and some of those components, I actually asked Justin to be up here with me today to make sure that we had some real expertise there. If you look at our agenda real quick, what we're going through is ultimately just a quick kind of high-level understanding of who NVIDIA is. I thought I knew what NVIDIA was before I came to work at NVIDIA, but it kind of blew my mind as to really their markets and what they do. They do a lot more than just that cool gaming company that has a cool logo and does neat things with LAN parties and things. Go a lot deeper into a lot other markets that I didn't know. So Justin will go into that in kind of detail. And then some of the stuff that we'll get into that we'll work through together is really, what are the markets? Especially why is NVIDIA here at a virtualization conference? And what are the markets? And who are the users that need a GPU? If you were in the last session with Sean Bass, you really kind of got a good idea of that these GPUs are becoming more needed, but why? And what type of users? They did a really good job segmenting that. We're going to go deeper into that understanding of either yourselves or your customers and kind of knowing where you should be thinking about a GPU, what GPUs, what are the offerings, what's going on. We'll then in turn get into, ultimately what is available today. We've heard a lot of things about vGPUs, VSGA, VDGA, all these weird acronyms. Well, we're going to try to decipher that. What's available today? What can we do? What should you guys be looking at? What solutions just absolutely aren't going to work for your users, and why maybe you need to be looking at one solution or another. Then we'll get into kind of vNext, of what is this grid solution that NVIDIA has kind of productized. And what does grid offer? What's really its differentiating factors in the marketplace? And then I'm going to bring some of the things that I've dealt with in the field as I was working for Citrix kind of to the party today. And that's really, if you're looking to do a proof of concept, you're looking to kind of roll this out, how can you do it really quick? If you want to do it bigger than quick, but quick still, what are the gotchas of getting this stuff rolled out fast, efficiently, and able to convert that proof of concept into an implementation fast. Then we'll take the POC kind of, let's just prove the point that it works, and we'll try to get into, all right, well, how do we now roll this into a production implementation? What are the components that we need to be assessing amongst our users? What do we need to be focusing around designing and implementing? And tips, tricks, gotchas, things that you should be kind of looking out for. So we got some feedback from the BriForum London that this was the type of content you guys wanted. So hopefully it goes through that in detail. And then throughout the time as well, please throw questions, let us know. If it gets out of hand and crazy, we'll try to push them towards the end. And we've still got our booth over there that we can go to. But definitely raise your hand, holler out a question. We'll do what we can to ask. Got a lot of content, so we'll try to speed through as best we can. Real quick housekeeping beforehand. For those of you, which I think is about the whole conference, because we had a whole bunch of people come by the booth, we had a survey running. And the survey was a special survey because it entered you to win the Titan graphics card. So for those of you who know what a Titan is, it happens to be the top baddest ass graphics card that exists in the market for gaming nowadays. I mean, literally there's nothing that beats it. And that's what our giveaway was. So if you have not filled out one of those surveys, please let us know. And this survey helps us actually define the marketplace and what we are doing from product roadmaps and such. So let us know, raise your hand, and we have somebody who will come and drop off a survey to you, and you'll be entered to win that Titan card. With that being said, I'll hand over to Justin to kind of go through this, what NVIDIA is all about.
Okay, can everybody hear me okay? I didn't do a mic check earlier. Yes, okay, great. So, geez, Jared, for a technical guy, 4 minutes on the first slide, man. I'm just kidding. So as a marketing guy, I know you guys don't want to hear from a marketing person at these shows, so I'm going to quickly crank through a few just kind of foundational slides to set the stage. Many people came by the booth, they didn't know how to say our name. They're like, what's NVIDIA do? The company is NVIDIA, but we're known mainly by people as the graphics company that delivers kick-ass gaming processors known as our GeForce boards, really on the consumer side. But we're much more than that. Over the last 20 years, we've built thousands of patents. We've become a really important brand, touching a bunch of different vertical markets. And so what we want to do is explain a little bit of that core IP that we've developed in the other markets, and then how we're going to leverage that into this virtualization space to really solve some of the world's most difficult visual computing challenges in virtual computing. Another question that people came up and asked, and I was a little shocked that people didn't know this, but we'll touch on it really quickly, is what is a GPU? What is a GPU designed to do, and how does it work? And so just really quickly, you guys are all very familiar with CPUs. They go into servers. There's typically these days you'll have either a single socket or dual socket server. Each socket has somewhere between 6 and 8 cores. But CPUs are fundamentally designed to be low latency, low throughput devices that are fundamentally designed to be a serial processor. A GPU, on the other hand, is designed to be high latency, high throughput. So it takes a little bit longer to get the data over to the GPU, but when you kind of set it up to run, it runs a bunch of tasks in a massively parallel way. So a GPU has up to 1,500 cores these days versus the CPU that has about 6. So application companies know this. They basically take advantage then of the right processor for the right job. And the way that they do this is they write their applications to either take advantage of DirectX or OpenGL or CUDA to offload the computationally intensive tasks that the CPU is not good at off to the GPU. One of the best examples of volume applications that take advantage of this would be Windows 7 Aero. So the desktop compositor that's built in Windows 7, when you're literally moving Aero glass window across a themed background, what's happening is you're blending the foreground and background image. And that's, again, massively parallel task. It's pretty simple computations. If you have a processor that's massively parallel, it happens instantly, and you get higher interactivity with those windows. If you do it on a processor that doesn't have a massively parallel processor, there's some latency in it. And so what we want to do, obviously, is go make sure that the desktop experience that everybody has on their tablets and smartphones and notebooks is the same experience they've got from an interactive standpoint when you move those applications into the data center. And that's really what we're doing with NVIDIA Grid. Just to frame this a little bit too, you again maybe have heard of NVIDIA GeForce, which is our gaming brand of product. We've got products that span a bunch of different markets, and we've got 3 core pillars to our business as we go forward. So we're focused on our core GPU business still, which is all about delivering best-in-class gaming experiences. We're using that same GPU architecture and putting them into data centers for high-performance computing centers. So some of the world's fastest supercomputers now use this parallel architecture for accelerating computing. The Tegra business is a system on a chip that goes into smartphones, tablets, and computers. So we've got an ARM-based CPU and GPU combination that's sitting in client devices, and with our Grid products, we're then putting GPUs in the data center as well. So you got both endpoints that can work with each other to deliver these really rich, fast, interactive experiences. What we're starting kind of our entry point into this whole virtualization space with is our legacy in our Quadro business. So our Quadro business was the business that we built about 12 years ago. We started it. It's about $1 billion business. It's focused on addressing the hardest visual computing needs in a number of different vertical markets, primarily through workstation OEMs. So there's a bunch of industries where you need to have high levels of detail and realism to do your job accurately. A good example would be within the manufacturing space. If you're a product designer, your job is to virtually design the product and find design flaws as early as you can in the design process, because the longer the flaw sort of persists in the production of a product, the more expensive it is down the road. And the way that we enable this, obviously, is working with key ISVs. And I'm going to skip this because I'll go through this. Okay. Is working with key ISVs and making sure that we deliver the highest levels of realism in those applications. And I'll give you guys some examples in a minute. So if we look at the market for corporate computers, there's effectively, some will say 600 to 700 million users out there. At the top end, we're talking about those designers that are using what we would call virtual workstations. They're going to need things like a dedicated GPU because they've got a large model that they need to load and interact with. But then as you move down the stack, you can start doing things like GPU sharing and potentially highly leverage a GPU in these entry-level use cases. And we'll talk about sort of how we can use vGPU in the future and the grid cards to address all these users at a really reasonable cost. And the benefit actually is going to be that the virtual machine itself has direct access to the GPU for doing the rendering, and it gets rid of the hypervisor or any other software interpretation that might be going on there so that you get the fastest, most interactive experiences. Some of the applications where GPUs are really a must-have, as I mentioned, is at the high end of the market. There's these design applications from companies like Autodesk, SolidWorks, PTC. As you start to move down the stack, where they must have a GPU to do their job, would be in some like product lifecycle management use cases. So in a manufacturing company, you'll design a product. The designer will then check that product into a product lifecycle management system. And then non-authors of the content downstream for quality control, for manufacturing purposes, for sales purposes, will have to access those models. And so they want the highest levels of realism, and a GPU is required to deliver that. Benny and Sean just talked about the fact that Microsoft Office, a lot of the new features that are visually interesting run using DirectX. So it requires a little bit more GPU horsepower, but those features are frankly nice to have. And we are obviously focused on where a GPU is a must-have feature because that's where we can't sell virtual solutions and we can't enable customers with virtual desktops without a GPU today. The future of the web is all going to HTML5. This is all driven by the proliferation of mobile devices. Mobile devices don't support plugins like Flash plugins. So for any rich interactive content, everything, whether it's 2D animations or WebGL or video decode, all of that takes advantage of a GPU through HTML5. And so that's going to be a big important feature for customers in the future. And as I mentioned, Windows 7 and Windows 8 and features like Arrow are nice to have features. They're not must have, but it makes the experience slightly better from a visual standpoint. As I talked about kind of the highest end part of the market, and that's our focus first, is if you look on the left, a designer that was using an application like SolidWorks today, if they're trying to run a CPU rendered graphics, they would get this jittery experience, and they would, and I don't know if you can notice this, but on the right there's things like shadows and lighting turned on, so you can look at the model in more realism. On the left, that's disabled. And so our goal is to maintain the visual realism that people have at their desk, even as you move these applications to the data center. The other side of this is, as I mentioned, the visual realism. A lot of applications, whether they're from Autodesk or PTC or Dassault or any others, will try and degrade gracefully, but the degrading gracefully translates into the application will run, but the visual realism decreases quite a bit. And so we just want to try and make sure we maintain that. And so that's going to be a huge thing that we keep pounding on. I mean, from our standpoint is, it's great that there's a bunch of new graphics-enabled solutions coming out on the marketplace, but our number one goal is how do we make sure that the user has interactive, full interactivity with their models, and they have, all the graphics, performance, and capabilities that they need, so that the application experience doesn't degrade. It doesn't go from looking really real to just looking blasé. And the only way that we can do that is by delivering the true GPU experience, which means there's nothing mediating the discussion between our driver and our graphics processor. And so that's why these solutions that are highlighted in green are the solutions that are going to give the user the native experience that they've got at their desk, using those applications as they move over to these virtual computing environments.
So there's a couple of things up here. If you look, the gray's not showing up very well, so you can't see that, which is probably fine because the green are the better ones to focus on. If you look there from Zen Server, the one in gray that you can't see very well is actually a basic VM, no GPU, which is what we've all seen today if you've ever done anything relating to a Zen desktop environment on Zen Server. For Zen Desktop, we can also get in and we can do the VMware with no VM. We can do a WDDM driver there that gives us some limited functionality or software GPU. And then you see we've got the VM with the VDGA. So that's the direct graphics acceleration. If you're not familiar with it, this is the thing that's in tech preview that was mentioned in Sean's session and Benny's session earlier. So these are things that can be leveraged. With Hyper-V, Zen Desktop can still broker a remote FX session to some degree. And then we've also got the Hyper-V with the no GPU. On the Zen app side of the fence, we can do GPU pass-through. Sean and Benny were showing that with some really good videos that worked out really well that they were in the session before us. Thank you. And then VMware, we've got the VSGA, the VMs with no basic GPUs, and then again with Hyper-V there, we can do that. Don't forget right now, it actually blew me away. Now that I'm on this side of the fence from a Citrix perspective, now I'm over on NVIDIA. I was at one of my customers that I've been working with for 5-6 years. And I come to find out that they have had 100 or so physical servers that had Quadro cards in it for the last years for handling radiology and oncology delivery, and it just worked. They just had it over there. It was something they were always doing. But from a Zen app perspective, a blade server or a rack mount server with a GPU, just bare metal, is a fantastic solution that's been happening quite some time in the HGX 3D space. And that was something that they've been using. And then, of course, we've seen a lot of customers, now that I've really gotten a broader look at the marketplace, being at NVIDIA, there's still a ton of customers out there that are doing blade PCs with GPUs. They're literally taking the machine from under the desk and putting it in the data center stacked on top of each other, and now using those as machines that they're brokering out to people as kind of blade PCs, but they're not really blades, they're physical machines. And then more of a rack mount workstation or ad hoc rack mount workstation. But these solutions here that we're talking about are what we're going to go in more detail through. So if you look here, right out of the gate, this is something that's supported today. GPU pass-through with a Zen app infrastructure. So if you're familiar with the Zen app or the Zen Desktop 7 app edition, we can take those GPUs, and that can be, if you're looking at the K2 card or the K1 card, that can be 2 of these cards with 4 GPUs that we're passing straight through to those VMs. So now they've got a fantastic GPU able to serve that out. And we can intermingle those with non-3D virtual machines as well. So when we pass these through from a Zen Desktop perspective, 4, 8, whatever we can put on the box, and I'll talk about sizing of how much memory and things and how many we really can get on a box in a minute. And then we've got the Zen app scenario here. So from a Zen app, we can do the session-based virtualization. So difference between these two is this is going to be a Windows workstation VM or Windows 7, Windows 8, and this is going to be a Windows server where we're doing Zen app 7 or Zen app 6.5. And now we can do the OpenGL enablement stuff that Sean was showing earlier. So a couple of easy mode scenarios that work really well. The question I get from you guys a lot, and I got it at the booth today, or over the last few days, is what does VMware do with support for Citrix or support for View and those types of scenarios? And here's really what it is. And a couple of useful tips here, that VMware has 2 solutions, one that's completely supported now, the other one that supposedly will be fully supported any day now. And Citrix has actually already tested both of these. So if there's a CTX article, if you want to jot it down, it's the 136291 that actually goes through the testing and what's happened with the VSGA and VDGA. But those 2 solutions, if you're not familiar with them, one is the shared graphics acceleration, and one of them is the shared or the direct graphics acceleration. So equivalent to an API intercept model or equivalent to a GPU pass-through. So 2 different models. And then it is important to note, as Sean and Benny mentioned, that in the VSGA model there is a limitation. So there's a limitation of the OpenGL 2.1 and then DirectX 9. But those are things that are available today. So let's dive into, really quick, Zen app, because this is the big one that I think Citrix has done a really good job enabling. Prior, it was just DirectX kind of support out of the box if you put a GPU in it, so it did some good things. But nowadays, that if I put a GPU in, I use 7 or I use the OpenGL enablement pack, I can get DirectX or I can get OpenGL functionality in a Zen app server now from session-based. So here's how it looks. I've got my GPU, and in a bare metal model, this is the customer I was describing earlier. We've actually even had some customers that have been able to get the K1, K2 cards working in a bare metal environment. So putting a K2 in a bare metal server, installing down Windows 2008 R2, XenApp 6.5, the OpenGL enablement pack. You do have to go and disable the onboard GPU, and now you have no way to get to the server, so you have to put a VNC solution on it to get to it. But once you've done that, you get really great results. And some of the things that I really dig about what they've done with the XenApp solution is they've made it so auto load balances. So if one user hits the server, it hits GPU 1. If another one hits it, it hits GPU 2, and goes back and forth between the two. And we're seeing really good performance numbers with leveraging the grid and bare metal. So what if I don't want to do bare metal, or what does it look like kind of in more detail here? So in bare metal, you've got your CPU, your storage, your memory, your network, you've got your GPU. We install NVIDIA driver. We're going to talk more about why NVIDIA drivers and these things are important. And I've got my session-based virtualization, which I think everybody understands in this room, specifically how XenApp works. With the OpenGL enablement pack, this is the cool part, is I've got full DirectX, full OpenGL kind of compatibility here, or I've got the XenApp app edition that gives me that functionality too. So 2008 R2 or the 2012 are all supported for this bare metal. So here's what it looks like in a VM. So let's say we put one K2 card in a host, and that host now has got either VMware or it's got Zen Server from a supportability perspective, and now I'm doing the GPU pass-through or VDGA or GPU pass-through. So I actually would pass these cards through to VM1, VM2, and now we see those cards presented. And when you're doing GPU pass-through, you're literally going to Device Manager and you're seeing a GPU right there. Then we're installing the NVIDIA driver that you would go out and grab from NVIDIA.com right there in the VM. It detects it. You have the NVIDIA control panel. You have all of those functionalities. Then we're either in a 7 environment, we're installing the VDA, or in a 6.5 environment, we're installing full-blown XenApp. And once we're done there, now we can broker out either full desktops and or just published applications. So just like what you would expect. So from what's available today, what's supported, that's kind of the solutions. We've got the GPU pass-through for our Zen desktop solutions. We've got the GPU pass-through and a bare metal for the XenApp solutions. Gives us the ability to do a broad range of OpenGL DirectX support. If you were in Benny and Sean's sessions, you saw the fantastic capability. They almost didn't highlight it a bunch, but every time they did show it, it did a really good job up there in the right-hand corner. Every time they brought it up there, they were doing more of software solutions. But I think Sean mentioned something that it wasn't fair because there was a real GPU in there. What we're going to focus on today is that's the now. Let's focus on the grid and where we're heading. And from a grid perspective, it's really made up of two components. So in the grid, one thing that blew me away about NVIDIA is they have an unbelievable amount of developers. What's the number? Something like?
Well, 2/3 of the company's software development.
So a company that makes graphic cards, but 2/3 of the company is software development. So it was amazing to realize that I thought they just made graphics cards all day long, but there's a ton of software work that goes into it around tools and things of that nature. And so the grid solution is made up of two components. It's heavy in the software, the drivers, those components, some tools that I'll talk about that are useful. And then it's obviously the K1 and the K2 card right now that are available. So let's look at the K1 and K2 card just to give you kind of a brief example of what they're about. From a hardware perspective, a lot of people come up to me and they say, I want the K1 card because it's bigger, it's got 4 on it. And they don't realize that the K2 card is actually the most powerful card that we have. And it actually has 2 as of a week or 2 ago when we announced the new Quadro card. It used to have 2 of the most powerful GPUs that we made are on this. So if you look here from an equivalency perspective, the K2 has 2 of the Quadro 5000s on it, so for a total of 3,072 CUDA cores. So it's a beast of what it can do. And then the K1 has got 4 of the K600s on this. And then we're able to do some really, really neat things. And from a dedicated perspective, we've got 2 and 4, so here's kind of the price breakdown of how this works. We've got 2 from a dedicated perspective, gives you an idea of what the cost is per user. So you're looking like $1,875 per user for if I was doing just 2 users on a K2, or the other numbers there. So Point being is this people had asked us a long time ago, we want to use GPUs, but we want to use them more efficiently. We need the NVIDIA drivers, and we need some of these other components. And all these terms you've heard around vGPU and hardware vGPU and what we're doing. Let me kind of describe to you what's going on in this new world. So,
well, and to set this up really too, so going back one slide, I think the point is, if we go back to this slide, the Grid K1 is offering the entry-level Quadro K600 equivalent GPU, and the Grid K2 is the high end of our Quadro lineup. And there's about 4 graphics cards in between that we can't deliver with these 2 cards today. And so what we want to be able to do is virtualize the K2 to be able to address kind of the volume workstation part of the market, which is somewhere in the middle. And then also be able to take the K1 and create the entry-level graphics so that the same graphics experience you have in your notebook or tablet, you're getting through an entry-level virtual desktop as well.
So we've had a lot of questions, and we've kind of only talked about vGPU in the sense that you're going to be able to take I think the terminology we've used is you're going to be able to take one of these cards and chop it up. But we're going to go into more detail of that chop up. So it's actually the first time I think we've publicly talked about it ever. Hopefully we won't get in trouble.
Well, the profiles.
The profiles, yeah. So here's how this works. We've got a GPU that we throw on the server. We've got our hypervisor infrastructure. From a hypervisor infrastructure, we actually install a Grid vGPU manager. So if I've got Zen server, the Grid vGPU manager is it's an RPM install. So that RPM install has got to be installed in the hypervisor. Once that's now installed in the hypervisor, it kind of takes ownership and understanding that there's a GPU or multiple GPUs in the hardware. So once we do that, we now present to the virtual machine. So how many Super Zen server geeks do we have in here that know the command line? Okay, 1. All right, so for you 2, we're essentially doing an XM param add. So we're going to go into the VM, call the UUID. We're going to add the vGPU profile to that parameter. And I'm going to talk about what these vGPU profiles are in a minute. So we add and we pick. We've got a list of the vGPU profiles that we add. When we add that, it allocates a specific amount of frame buffer and then correlates to the GPU, and now that machine physically appears in this device manager. It's got a device that I'm not sure what it is until we install the driver. Once we install the driver, it now knows it's a NVIDIA K2 with the name of that vGPU profile because it figured out what it was. So now we've got a physical, as the virtual machine itself just thinks that there's a card installed there. So we install that component, the embedded driver. And once we've done that, the thing that the vGPU manager does is it communicates state back down to the card itself. Beyond that, we actually just do all of our graphics commands outside. As Justin alluded to earlier, we just get out of the way. We get the hypervisor out of the way, we get everything out of the way, now we communicate directly to the GPU, and we're able to keep that performance up and have great performance there. And now we can carve it up more, and we can carve it up more, and we can carve it up more. So this is the piece that I don't think we've shown to anybody, but I think we wanted to do it at BriForum here. But this is this. So it gives you guys an understanding of our vision of where we're heading with the profiles. So let me explain this a little bit. You'll notice at the top part, there's a couple of things to take note. The first one is these are the naming conventions of the profile. So eventually, I think from a Zen server perspective, you'll have a drop-down box right in the VM where you just select that profile and voila, you're good to go. If it detects there's a K1 or K2, you'll have these different profiles. You'll just assign that profile to that VM, install the NVIDIA driver, and you're off and running. So it will be very, very simple the way that this is going to work. The neat thing here is you see the queues and the not queues. So what's the difference? And maybe you can allude to this because you know it better than me.
So yeah, the queues basically are going to go through the same rigors of our Quadro product lineup, which is designed for workstation users. So that means we work with the ISVs. We basically have the ISVs do application certifications on top of this, make sure all their shaders run. They get the full experience that people would get at their desk through these virtualized profiles. So that people have the confidence that it is the exact same graphics experience that the ISV recommends through a virtual desktop as they get at their desk.
And then the other ones are more commoditized. Question in the back?
Is there any tools that can kind of show that? Because someone that's used to have a workstation underneath the desk and also take it away, they'll throw me as a jet. Right?
Sure.
Are there some tools that you can kind of use in the virtualized sense that can show efficiency or?
So there's a couple of things that are happening in the space, around your assessing your lakesides and things of that nature that are starting to include some of the GPU components. The reason why, and it may not come as we're virtual people. There may be a handful of people in the room that are graphic, workstation people. The idea behind the profiles and the naming conventions is those happen to be similar naming conventions to what they might already have in their workstation. So if they need a specific GPU type, it gives them now the ability to kind of go and correlate, well, this is what they kind of had before, so this would be the virtual equivalent of that vGPU profile that I need to assign to them. So we're trying to make it as easy as possible to kind of communicate that down. Yeah.
So is that virtual desktop Zen app that you talked about here? I guess my question
No.
is, this is Zen desktop.
This is Zen desktop.
The card is not locking in, or the manager is not locking in the VM to that specific GPU the entire time. It moves it because you're saying you will have 4 physical cores for 32 users. So I'm just wondering how technically that works.
No, for the first release, we're binding it to the VM. So that vGPU gets bound to that VM, and it's there. From a roadmap perspective, there's obviously that question you've asked has been addressed. But initially in phase 1 or the tech preview that you'll see here in a couple of months, it'll be bound.
So is this profile referring to the hardware you have or a portion of the hardware?
A portion.
Okay, I'm not getting that.
It's a portion of the hardware. So if you look here, this is the amount of physical. This is associated to the actual physical hardware, what we've got in there. And now, so let's take a K2. I'm actually going to be able to get that many users on that. So 4 core board, 2 per processor. So that's a 4 model, and that's how much.
To take that example, so the K2 has 2 Quadro 5000 equivalents. Each has about 1,500 cores. So if you put 2 users on one of these GPUs, you then are giving them about 760 yada yada cores, worth of performance. And I mean, the way I would think of it, and about half of the frame buffer that's assigned to that GPU. So it has 4 gigabytes, they get 2 gigabytes. Yeah. Yeah, so, and then the question always gets to, well, how many users can I put on this? What equivalent product is this like? And the reality is it's application specific. So this is where we're always going to say, well, your mileage may vary. What we're trying to do is use the industry leading applications and do scalability, like testing with specific data sets with those applications with a certain guesstimate of concurrency on that server, so you can get to like how usability will scale on those servers.
Question in the back.
Not really a question, it's a comment back to the original question. I happen to have had some significant conversations with Lakeside on this particular subject, and I would strongly recommend that anybody's interested in what's been talked about here, to talk to the guys at Lakeside, because they are working on stuff that will allow you to run their tool against the current physical environment, and then against the virtual environment with specific applications to be able to do exactly the comparisons you're talking about. I don't think it's been released yet, but I know they're working on it.
We're talking with them. I mean, that's about as far as I can go, but there's a lot going on there.
I figured you were a little more limited in what you could say.
Especially because there's a camera right there.
I know that's what we get as far as the questions that they're going to say, hey, doesn't the same.
We totally understand what you're asking, and we are doing everything we can to make sure that we can deliver or work with the people who can deliver that type of thing to the market.
But, and I think, to your point, one of the things that we have found, the best way to show somebody that it's equivalent isn't to argue speeds and feeds and performance of the hardware and the server versus what's at their desk, and to give them access to a virtual desktop. So part of what we'll talk about is how to go about piloting this in a simple way to prove to them the point that the experience is the same, and then move down that path.
There's some paradigm shifts in what I think all of us coming from a virtual space are going to have to deal with. The paradigm shift isn't speeds and feeds and cores and IOPS and all these things that we're dealing with. It's CUDA cores, it's memory throughput, bandwidth, and then it's also kind of correlating to the world that maybe some of us haven't dealt with a ton in what the specific card is and what type of applications it works with. Some of the customers I'm dealing with are dealing with 5-7 day renders. It takes that long to render a job, and so for them, if it takes 4 days, because now they can dedicate super fast storage, super fast everything, and then just start the render, disconnect, walk away. They don't care how much the solution costs. because the developer can get back to work and get going again on something, whereas before their workstation was tied up for that period. There's a lot of things, and this is what we're trying to kind of bring to this session, is just to understand that there's a lot for us to learn. In a minute, I'm going to go over like the ISV applications. It's important to know if you see these type of applications within your customer base or your environment, it may be good to start understanding that this specific GPU pass-through is the solution that's going to work for them or not. So we'll do our best, and from a messaging and from a NVIDIA Grid website and blogs, let us know the type of things that you're looking for. I think that's a big message that we can get out to everybody is help us help you, because we're not entirely sure what you guys need, and we want to make sure that you have it.
Just from the user standpoint, since you present, on the virtual desktop, you're going to get the standard NVIDIA control panel. Have you considered doing something there in terms of masking it to the equivalent card, or this is performance equivalent to this card? So when the user looks at it, they can see and go out to the ISV website and say, oh yeah, it's the same.
So I think
we spend so much time, like I would love to be able to make it that simple to the user. The challenge is because of concurrency. So the user, typically at their desk, they've got a dedicated GPU, but as soon as you put it in the data center, there's concurrency questions that come into play, and obviously the performance can change as you've got more load on the server. And so as a result, we didn't want to try and do the direct mapping within the control panel. We wanted to be really clear, like in the naming. So obviously the grid K1 or 2, the leading number kind of says the GPU that they're physically running on. So if they file a help desk request, you can kind of figure out, are they on, which virtualization infrastructure are they on? And then the others kind of scale based on the performance or the size of the frame buffer that's available to them.
But then you're getting these virtual GPUs certified at the ISV level.
Exactly. Yep.
So that user can go out to Dassault's website and say, yeah, I'm on the list.
Exactly. Exactly. So it'll say the specific driver version that's certified with these vGPU profiles on Dassault's website or PTC or Autodesk or the whole game.
I didn't realize how big this was. It's a virtual driver or whatever. New. That is not the case. These big, when you're spending $5,000, $6,000, $7,000, $10,000 on a specific CAD, CAM, CATIA, or whatever these solutions, those vendors want a driver version. They want an engine I'll talk about called the ACE, Application Configuration Engine, where it's an NVIDIA tool that'll go and configure the application based on the performance of the machine. Things like that are extremely important to a lot of these high-end or even mid-tier or even gamers. It's an interesting space. So let's move on, or we're going to wind up never getting finished.
Let's skip this.
So this is the point from an ISV perspective. This is just a small list that you can't see, and I think we'll make the presentation available so you can get smaller into this. And this is also out on our website, and there's one on Citrix's website as well, and there's one on VMware's website around the view with GPU solutions. But these are just the different driver versions, the different types of solutions that are supported, and it just goes into this ISV certification stuff that's critical when you get into these type of investments here. So, many times, ultimately, what you're dealing with is they require a GPU or they require a specific driver. So, two examples, a few of them here is CATIA and SolidWorks. They absolutely have a whole ton of features within their products that just will not work without an NVIDIA specified or certified driver version or a card. In the SolidWorks, if you've ever installed it with maybe a lower end card and it doesn't work, it's probably because there's a whitelist that the card has to be in that's approved. But some things of that.
So, and I think the easiest way to understand this is anytime you see somebody saying, we only support up to API XYZ, you're going to have application compatibility issues with a lot of the professional ISVs. So, for, general knowledge workers, those virtualized graphics applications are great. But as you get into what power users need and designers, you need to have, all of the graphics APIs supported to deliver them the native experience.
Do we expect support at launch from Dassault for CATIA? I mean, that's down the path?
Yes. So there's actually a whole list that we've published on our website. So if you go to nvidia.com/grid certifications, there's certifications that have been done with pass-through right now on HDX 3D Pro, and the virtual profiles will be added there when it becomes available in the market.
And it actually also will tell you, it's kind of nice, it'll tell you if they're pending, in process, so you'll know if it's even on the radar. So we're trying to make it as helpful, and I don't think it was really hard. We're just pulling from what they've done, what NVIDIA's done for years and years before.
We're trying to pitch a solution that matters to everybody.
It's nice to be able to go to that customer though and ensure to them that look, we've got supportability, or look, it's pending, and it'll be right around the corner. So things like this control panel are some of the things. This is things that aren't just used in the gaming. For those gamers in the room, you know about the NVIDIA control panels. You can go and tweak and turn on things like the anti-aliasing, optimizations that you can go in and tweak as well. So this is the stuff that we bring. And then the engine I was referring to is the application configuration engine. These are pretty cool. And when you're deploying these things, make sure you're leveraging these tools, especially with your higher end applications, because these tools can go and configure settings, or they can optimize the overall graphics card for the performance of the solution that you're dealing with. The place where I knew about this, especially like the configuration engine, is in gaming. From a gaming perspective, these hardcore gamers in the room, you go in and you look at the options menu around graphics, and it's like, woo, what is all this stuff? And you got to be kind of a mad scientist sometimes to learn how to turn all those dials to get the best performance. They took the technology that they did with that and applied it into the enterprise CAD, CAM, all these other spaces. But literally, it's just a one button, figure out what my machine is, and auto configure the graphics card for optimum performance. So it's kind of slick. And I'm sure you'll see a lot more evolution around this. But again, just some of the benefits of the card. So one question I get all the time is, this sounds cool, but what can I put it in? Can you give me a card? Because the first question I'm usually going to ask you if you have a card is what hardware platform do you have? And the reason being is that you'll notice if you've looked at these cards, there's no fan on them. So it needs to be an appropriate thermal footprint of a server to handle this card. And here's actually the platforms that are currently supported today. The list is this, and it's growing, and it will be growing, and there'll be neat new things coming out shortly. So available very shortly are the HP lines, but then you've got your Asus, Cisco, Dell, IBM, Supermicro. Each one of them have a platform that support these cards today. Most of these will support up to 2 of the cards in there.
Are they any type of specific footprint in terms of half height or anything like that? Or?
They're big. There is some other options that aren't specifically grid related. Yeah. There's some other options as well that we're not going to go heavy into because they're not out of the grid family. They're kind of in the Quadro family, but there's some SMX modules that can go into some blade chassis and things, but you're going to only get the one-to-one with those. They're not virtualizable like you can do with the grid platforms.
I guess the question is, would it fit in a half height slot or a full height slot? Full length.
Full. Yeah. So, and these are the platforms. So, I mean, the key right now is if you're looking to do this, if you've got customers or you are the customer, communicate with your HP, IBM, Dells. Let them know what you're trying to do. Make sure you're adding in a GPU add-in kit. If you've already got one of these platforms, there's a kit that you need to add that typically is nothing more than power cables to plug in the card. But it's important to know what you're trying to get into here.
I was wondering about power requirements and needing those extra power cables.
You do. Yeah. Just like just if you slammed one of these cards in a gaming machine, you got to plug 2. So the K2 actually requires an 8-pin and a 6-pin, and then the K1 requires just a single 8-pin.
How many watts does these cards draw?
240 from the K2 and 125 on the K1. All right, so we get into kind of my fun part around POC lessons learned. And this is through working with a handful of customers when I was kind of at Citrix, and there was some pain, there was some lessons learned, there was all kinds of fun stuff, and most of the things that I dealt with were around GPU pass-through. GPU pass-through, some remote effects things, some early days of VSGA on VMware, trying to get that to work into the Zen desktop environment. But I wanted to give you guys at least just kind of ideas that I've had when I was out there deploying this stuff that helped me throughout my kind of making things be successful. If any of you have been working with Citrix for a while, you know about the basic kind of concept of assessing, designing, deploying. And most of you are consultants, so a lot of this is I'm speaking to guys that probably would be able to speak this back to me just as good. But it is important to understand what we're trying to accomplish. And if you guys have seen here around assessing your user types, what type of machine are they on now? Some of these are really critical. So I kind of put together a checklist of things that were important. You need to figure out right out of the gate, is this going to be a XenApp user? Is it going to be XenApp Zen Desktop? Some of these different kind of assumptions, define them, and figure out what you're trying to do. And before I even go here, I'm going to mention it in a minute, but does anybody know the quickest, easiest route to HDX 3D Pro POC that exists? Starts with a remote PC. So, yeah, I mean, the thing is don't overcomplicate things. If you're just trying to prove to your engineers, because they're being a pain, and we know they can be a pain sometimes, if you're just trying to prove to this customer that you want to, like, let me just show you this stuff does work nowadays. I know we tried it 3 years ago, and I know it didn't work, but if you just want to, like, prove a point really fast, really simple, anybody have a DDC happen to be laying around? If you've got a DDC laying around, even if it's an older one, not 7, you can still put the new 7.0 VDA on that physical guy's desk, under his desk, register it as a machine, and broker it within about, how long, Steve? 15 minutes? So if you're looking for just a quick, easy POC, simple out of the box, just to prove to that guy or girl that it works, that's what you guys should be doing. It's easy, it's simple, and it's just giving them access back to it. And there's some caveats that Sean's going to remind me of.
Some of the early releases of the VDA remote PC were only supporting thin wires, so you wouldn't actually get the HDX 3D Pro, and now in version 7 it's the same.
It needs to be 7. I think that's the biggest caveat, is as long as it's the Zen Desktop 7 VDA, it's easy mode, it's fast, it's simple, and you can do all those cool things and be cool like Sean that he was showing in the session before. Very quick, very easy, very simple. That's the easiest way to do this. So instant POC, and we don't even have to go over this POC lessons learned thing, because that's the biggest lesson I learned, was instead of building up a hypervisor infrastructure, trying to get somebody to get me cards, getting all this stuff in place, passing them through, installing DDCs, all this stuff to get a POC up, if I would have just installed the VDA on a machine, I would have been done. So that's the fastest, easiest way. But if we are going to build out an infrastructure, a couple of things that are useful. Remember from a core perspective, well, there's a couple of things. I'm not going to go through all this. We won't have any time. But from monitor support, that this is the biggest one. If you've got engineers, developers that need massive amounts of monitors, you need to be on 7. Zen Desktop 7 gave us 4 monitor capability. 5.6 is 2. So this is the biggest thing I see as a problem when I'm out there, is because you've got engineers that have multiple monitors. You're going to figure out real quick what you have to do. You might figure out right here in your POC, I have to bring a 7 environment up. If you don't know, or if they need huge amounts of monitors, NVIDIA supports a bunch. Yeah.
Do you have a recommended tool for monitor profiles for doing the virtual monitors?
No. That's a whole nother fun part that I'll talk about in a minute as well. But the sizing and all of that. I mean, a lot of this stuff is you're gonna work through it and read through, the blogs that we're starting to create, the blogs that Derek Thorsland and that team's creating, and I think Sean's got some of the best stuff out there as well. That's there. And so this is a really busy slide, but it was the easiest way for me to cram this on here. But just strategy, tips, tricks, things to kind of remember as you're going through this. Use your existing workstation, remote PC. Told you. Start with Windows 7. Always start with more CPUs and memory than you think. You're almost guaranteed to take a couple of CPUs or vCPUs just to deal with the kind of compression and those types of things that are involved. So definitely start with 4 CPUs and a minimum of 4 gigs of RAM. And if you're doing XenApp in a virtual environment, you're talking more like 4 to 8 CPUs, vCPUs, and somewhere in the realm of up to 16 gigs of RAM. For that type of delivery model. It's a lot more. It's not like we were dealing with our old machines where we were trying to give them 1 and 512 megs of RAM. we're giving them some serious resources here in these HGX 3D Pro environments. If you look at the top left there, designers and engineers are going to be guys typically that are going to be a GPU pass-through model. Not always, but typically that's the model that they're going to be having. In a healthcare scenario, it might be somebody who's doing some heavy-hitting radiology type stuff that might be a GPU pass-through, or it might be a Zen app with a dedicated GPU. That's the model there. In a CAD CAM and engineering type firm, editors and viewers can almost always get away with Zen app with a GPU pass-through. So Zen app is always the model that typically works there. And it works really well now with the whole OpenGL enablement pack, Zen Desktop 7. It works really, really well. I've told many of you this that came by my booth, 7 for 3D moving forward. There's just no point in trying to do this on 5.6 or 6.5 or any of these things. The amount of work that has been put into 7 around this is significant. Don't bother doing it on the other versions. You saw some of the, if you were in the Sean session, you saw some of the bandwidth that was there. You're delivering fantastic solutions at under 2 meg of bandwidth in a 6.5 or some of these older. That would have been, Sean, what do you think? At least 2-3 times that?
I don't know, maybe 30 or 40%.
Yeah. So it's come down a lot, and it's just a lot cleaner, lot better experience. So other things to kind of remember as you're going through this is baseline. Monitor your CPU. Monitor your, typically in a POC, you're going to do 1 or 2 types of users, but create a baseline and monitor those users. Make sure you're understanding what the bandwidth was for 1 session, 2 sessions, 3 sessions. Make sure you understand how much memory, how much CPU, what was going on in that type of a scenario, so that you can extrapolate that baseline out times 1,000 users. I have users come into me all the time that'll say, yeah, we've got 1,000 CAD CAM users that want to do this, and they're only testing on 1 user with 1 concurrent, and they're making their whole entire decision off of that one thing. You've got to actually try to extrapolate out and measure these things to figure out what it's going to do in your environment. All of the basic Citrix, Zen Desktop, VMware View, all these typical design things apply, but they're kind of more nasty. Remember your storage, remember your sizing, remember all of those best practices that you came to BriForum to learn about, because they just will bite you harder in a 3D Pro environment, because they're gonna rear their head faster and a lot more aggressive. One of the things is measure your GPU utilization. Understand that specific users, this goes back into some of the questions we got earlier, is measure this stuff. Understand that if I've got people kicking off a 5-day render, what does it do to my GPU, and what's it going to do to that other user that's on the environment? So there's really cool tools. NVIDIA, this is when you install a driver, you've got this cool tool, NVIDIA.SMI. You can even loop it so it just sits there and runs. And you can output it to a text file as well. There's some cool things you can do with it, but it'll give you the overall utilization on memory and GPU consumption. But it gives you a snapshot or a looped result of what that is. And then use other tools like this to make sure things are working correctly and something hasn't gotten screwed up. So when you're measuring the GPU, there's kind of a couple of cool tools. There's a whole bunch of them, but these are some of the ones that I like. I like Caps Viewer because it gives me the ability to kick off a quick and dirty OpenGL or OpenCL type test tools that will actually tell me that, all right, I see the GPU. It'll tell me the versions, tell me firmware versions. Some of this stuff's pretty useful because if I don't have it, I'm not going to be able to open support tickets and tell Citrix and or NVIDIA what the driver versions are and some of these things. It gives me some simple basic tools to get this stuff out is the point. So user experience, it's extremely subjective. Somebody alluded to it in the back that when you're kind of going from a physical machine under your desk to a virtual environment, first of all, that can be a painful just experience because there's no longer a footrest under the desk, and sometimes it's very subjective of what the user thinks. But understand that when you're analyzing and going through feedback, up to 200 milliseconds of latency is typically the best environment that you're going to get. When you start crossing over 200 milliseconds of latency, we find, and Sean, you were 200 or 300 in your test.
We did 200.
Okay, so, and we were seeing that in the results there. But about 200, it's about fine is the point. And over 200 to 300 can be good. It just depends on the scenarios. It depends on the type of application you're trying to work with. When you're doing POCs, and this is any POC for all I care, avoid doing this on a shared infrastructure with your existing VMware or existing Zen server. Create a separate infrastructure for this POC just because potentially users can be pretty aggressive. Basic type of stuff here, but recommendations that could bite you. You wind up taking down your production environment because something negative happened. Remember to leave adaptive display on. It says here too, one of the things is that the Quattro cards, this is an interesting point, and I didn't update this from a previous presentation. It says use the Quadro cards in Zen app servers if you're going to do a bare metal deployment. The thing is that technically you're going to see documentation out there that actually says the Quadro cards are the only thing that's supported in a bare metal Zen app environment. But we've actually been seeing a lot more customers trying it with the K2, K1 cards, and they work. The big caveat to that, and if you're going to do this, just don't forget this one piece. You've got to make sure there's a VNC viewer, and you've got to disable the onboard. Once you do that, you can still get in to do it. It runs great, and it load balances. The new 7.0 load balances across all the GPUs that the machine finds. So that first statement is not entirely correct.
Are there thoughts of putting a local display onto the card?
I don't think so right now. I don't think that there's any. I mean, that's not.
Servers never die, or you never need to get into
Yeah.
BIOS or anything like that.
So you're just disabling the main one on that, which is the card on the back of it, is the thing, and then you can still ILO into it or DRAC into it. That's fine too, if you have that. But it's just the physical on the thing that you've got to disable, and that's it. Point being is we're doing more testing around it, and eventually you're going to see it be more supported. And it gives you a lot better density than a Quadro 2000 when you're doing two 5000s essentially in one card for not much more money is what we're doing there. So the other thing too is remember that that Citrix has produced HDX 3D check tool, health check tools. So remember once you've gotten this installed to go out and grab the HDX 3D Pro health check tools. And run those on the machines. They're pretty useful is the point. So to kind of summarize this really quick, make sure you understand the configuration that you're dealing with. User feedback is critical. Some of the tests that I've seen has surveys. It actually puts us in front of real people. They then in turn put down their experiences of what they like, what they don't like. Don't just willy-nilly it. It's important that you get that feedback from the customers. Identify your concerns, issues, and don't move on till they're resolved. I see people that just sometimes push the concerns and issues to the side and then say, all right, we're rolling out next week without resolving those things. I mean, you guys all know this. For capacity planning, remember to assess and understand CPU, memory, network, storage utilization. Storage is still a nasty one that can get us, and it can more so here, especially when we're pushing gigabytes of files across the infrastructure, because some of these big jobs, especially in the engineering space, are really big, and it can actually have a pretty negative impact on storage, a lot more than you would think. And then vCPU allocation per server. You're going to give more vCPUs to this type of machine than you did in the past, a lot more, and also memory. And then the last thing I'll leave you with is user density per VM, user density per host is going to vary. It varies depending upon what your users are, what they're doing, what apps they're running. But if we do a proper POC where we assess what it is going to be, we can know that number and we can scope accordingly. All of those questions that I'm going to get and that I've gotten all week from you guys, how many can I put on here? How many this? The answer is it depends. I don't know because we need to understand what your apps are. But if you POC correctly, we can know. And then we can scope and put the proper architecture together. So once we've gotten through a POC, a couple lessons learned, and then I'm going to open up for, 10, 15 minutes of Q&A here, depending upon how much time we have left. So this is the whole analyze, and I've been kind of covering this throughout the POC as well, so we'll go pretty quick here. But make sure you're analyzing what you're trying to accomplish in your HDX 3D deployment. Just like a Zen desktop deployment, just like a Zen app deployment, understand and analyze what applications, what are the users, what's the geographical location of where this user is, so that we can make sure that we can analyze and deploy this correctly. Designers, engineers for Zen desktop. It goes back to the editors and viewers for Zen app, Zen desktop. Make sure that you understand that there may be a vendor in your environment that has been producing software for you guys or your customer for quite some time, that has never heard of virtualization, that has never heard of any of this type of thing, and they might say right out of the gate they don't support it. But know that before you've gotten to the point to where you're going to deploy 500 of these desktops. So that part of analyzing and working with the applications that are going to go there, because this is a little bit more aggressive than the old days of MetaFrame, WinFrame, where people would just say, nope, we don't support it in terminal environment. Because we're kind of back at that again because these guys haven't been there. So it's important that we find out what the apps are and talk to those ISVs and let them know that, no, we can deliver this version of OpenGL. We can deliver this specific NVIDIA graphics card. We can do this version of DirectX, because a lot of times you'll be able to sway them. But they also you could put your customer in a world of hurt, or you in a world of hurt, because it might not be supported, at least right out of the gate. So a couple of things from a design perspective, and this is actually pretty easy. You guys have been here to learn how to design this type of stuff. The whole Citrix, best practices guide, Cisco validated designs, HP validated designs, the whole core design best practices all apply to this environment. They're just a little bit more critical, specifically around kind of performance tuning and those types of things. Your focus, design focus, you guys know all of these things. They're all a part of those core infrastructure design handbooks and things that are out there. But definitely, don't go into this assuming that it's an easier deployment because you're only going to put 4 or 8 users on a box or whatever the scenario is. Those are big, heavy-hitting users that you could be putting in there. One little thing I wanted to throw in here for you guys is remember to grab the latest or the appropriate driver for the application from the NVIDIA site for the VM. And make sure you put that on first before you do the VDA. If you put it on without that, you're going to have to uninstall a VDA and reinstall it, or you're going to have to go do a registry hack. There is a Monterey executable that's actually fixed now. That's another one. You talking about Monterey enable? Okay. Yeah. The VDA will enable that. If you don't, if you install the GPU, the driver first, the 7 VDA will do that for you. If you don't, then you have to go do that, and that's the point. So just keep it simple. Install the NVIDIA driver before you put the VDA on, no problem. Then we don't have to worry about it. But there is a workaround, and he's actually referring to the workaround because he probably put the VDA on first. All right, easy mode quick test is the NVIDIA control panel. If you launch the NVIDIA control panel and it throws an error, you probably didn't do something right. So that's a very, very quick and easy way. That's the thing that's in your control panel. Start, control panel, NVIDIA, launch it. If it fails, you didn't do something right. So pretty simple. And oftentimes the thing that you didn't do right was sometimes you have to go into the BIOS and you actually have to select or use the NVIDIA GPU or disable the onboard or one of those types of things to kind of force it there. So pretty simple. A couple last things, and I'll go to a Q&A here, is remember to enable VTD or IOMMU. It's important. A lot of these advanced features I see, and I get a lot of calls from people that they just seem to forget it. But make sure you enable these things in the BIOS of the host. If you're doing physical stuff, turn on your hyper-threading. There's a couple of Microsoft patches that are typically a part of a lot of the Citrix worlds, so Citrix documentation around performance-related roll-ups that are good to know. From a monitoring and tuning perspective, user density for XenApp, make sure you adjust your load evaluators. Everybody knows this stuff if you're a Citrix admin, but if you're new to Citrix and you're dealing with these, make sure you adjust these things and then apply them based on the useful kind of parameters, specific memory, CPU, or hard drive usage, and those things. The VM density per host, decrease or increase based on the number of VMs. It all comes down to assessing what we're trying to do. If we understand our user types and we understand those, we can make sure that we build these appropriately and put the appropriate amount on. You're not going to be able to get a whole bunch on without understanding where you're going. And then make sure you understand your VM configuration around and have that defined, documented, and understand why. Around vCPU memory and all of those different components. Well, we got about 9 minutes before we got to go eat lunch, or hang out with me somewhere, and we can keep asking Q&A. Is there any questions that we have before the 9 minutes is up and we're wrapped up? Yes, sir.
You talked about we need 2 vCPUs for machines, for virtual machines that actually use these cards. Is that because there's a footprint?
Well, what I was saying around the 2 is there's so it's up to 2 that just deal with encoding, decoding, getting the kind of signal out. You're typically going to give 4 to each one of these machines.
And is that overhead done by the VDA, or is that just the operating system?
Overhead dealing with compression. It's overhead dealing with the super codecs and those types of components that are in there.
Now, are some of those CUDA accelerated?
Not at this time. So hopefully, I think that we would envision that they would get there.
I guess I was hoping to see if the VDA is doing a better job now getting that stream of graphics out to the NetScaler or the Zen server or whatever.
So there is an option that you can do now. You can actually go into on a Zen desktop. You can turn on GPU compression or CPU compression. The reality of the implementation currently is the CPU wins. It's actually a better compression, which means I need to make sure that I have enough CPUs to handle that. I would hope that at some point we tweak the GPU compression to be better, because there's a lot of cores there that oftentimes aren't being all the way utilized. And then there's also H.264 encoders and decodes. But I think that there's work that still needs to take place with Citrix and NVIDIA, and we'll see where that goes into the future. But right now, Citrix has done a really good job with their CPU compression.
But if you think about it, comparing it to physical workstation, you're going to have 4, 6, 8 cores, maybe 2 sockets. So
exactly.
It's asking a lot.
It's really not, but it's a paradigm shift, and this is the thing I hope that everybody gets, is you've got to have kind of a paradigm shift. If we're replacing a $7,000 to $10,000 workstation under somebody's desk that's got 2 sockets, 2 quad core with 16 gigs of RAM, and a $4,000 or $5,000 video card in it, and we're going to put it in there, we're not going to give them 2 CPUs, 2 gigs of RAM. It's just not going to be that. We need to do that. Sean?
I was just going to say, we didn't make this very clear in our session earlier, but every single VM test that we perform with 2 vCPUs, and generally speaking, even if you're not doing 3D graphics, if you're doing any form of rich graphics like rich media, videos, WTF, that kind of stuff, you really want to have 2 vCPUs, because one vCPU ends up running into performance issues because of the fact that you're not able to do multi-threading effectively across multiple CPUs. So any kind of media-rich virtual desktop, you want 2 vCPUs.
Did you play with doing more yet? Like just give it 4 or 8 or something?
We did not, but it kind of follows a lot of the same rules of like your dynamic virtual desktop scalability. Like the 2 is the absolute bare minimum for rich graphics. Beyond that, the gains are only dependent based upon the applications you're running. But for anything media-rich, 2 is the bare minimum.
Yeah, Player actually seems to scale relatively well beyond 2s. Other apps do not. If it's a single thread decode, it's just that. That's what makes it different.
The main reason that you need 2 is because you end up with a single vCPU. You're competing with the compression of the graphics with the application that's running. One of the 2 of them are going to lose, and then you'll end up having stuttering and slowness. So at least with the 2 vCPUs, you can balance that out better. But going to 4 or 8 or whatever doesn't really help you unless your applications are well multi-threaded.
All right, any other questions before we wrap up? We've got the booth still over there. We'll be there, and come and ask us questions.
Final question right here.
Yeah,
Oh, okay.
you're it.
Obviously there wasn't a lot of talk of VMware and View in this session, but have you, NVIDIA, worked with anything with combining GPU acceleration with a Terra Apex offload particle protocol acceleration?
It's funny you ask.
And are there any benefits to that? Config? Is there any comments?
So NVIDIA is now, Justin and I just last night had got the question a couple of times at the booth. and we've sent them off internally to start doing more research around specifically GPU with an Apex, offload card, kind of the combination. There's been lots of stuff done with View and GPUs. Doing VSGA and or VDGA, and those are all fantastic results, and very similar to being on par with the stuff you'll see from a Citrix perspective. With the Apex card being added, no. I've got 2 or 3 customers that have just got them, and they have K2s. So I think very soon, maybe there's people like me and you that should get together and think about a blog post. So he probably can answer better than I can.
Yeah, the Apex is hardware. So if you're familiar with TerraG, right? When they started out, they had the host cards. It's just a single card you drop in and it did the DPI pass through, but it was hardware encoding of the protocol, and we have 0 clients to do hardware decoding. Apex is a server class, kind of like the grid, right? Like you have a GPU and then you have a grid that's meant for server class multiple users. Apex is a card that's meant to do multiple users, so you can hardware encode via PC over IP up to 64 displays. The number varies, so you can do more, but you can drop more cards. But it takes that off of the CPU.
It's specifically PC over IP.
It's specifically PC over IP. It's essentially, it's like a server class Terra chip.
It helps with scalability, as I've understood it. It helps with scalability on the
There are
host.
many use cases that if you're doing heavy encoding, learning, right, training, heavy where you're doing a lot of video, you can get away from the 2 vCPU model and go to 1 vCPU with an Apex and achieve better density, lower cost, right, whichever you want.
The one thing that I've understood, and correct me if I'm wrong, is that the Apex card does not offer, your higher end versions of your HDX or of the OpenGL or DirectX. It's not providing a GPU
Apex
per se.
Is not a GPU.
It's not a GPU. It's an offload.
It is a
Yeah.
It's a PC over IP encoding offload card. It's not a GPU in any way. And that's why, but combining it with GPU, getting hard PC over IP, if you're using a 0 client, especially for a higher use case, I think is an interesting.
We'll talk. I've got a customer that's got them, and I think we should probably all work on it.
I think we're going to get kicked out of here. So before we do, we want to quickly draw this card and make sure that anybody that's got a survey.
We have 2 minutes.
Draw my card.
Yes, we want to draw your card. So make sure we have it. Thank you. All right, Titan GPU. Cool, thank you. So, and while we're waiting to do this, Jared just put this up, grid resources. You guys make sure that you sign up for the newsletter. We're going to have ongoing updates of applications as they get certified going out through these newsletters. And any questions, like literally that grid team email alias goes to everybody that's working on grid within our company. So look forward to hearing from you guys.
Who's drawing?
You are.
No.
Yeah.
No.
We're giving you all the hard jobs today. Come on, Jared.
Yeah, that way it's TechTarget's fault.
Is this your card? There you go.
Marc-Andre Moreau.
Yeah.